Hello class, my name is Nawaf. I'm here with Robert and Chris, and we're going to present to you the fundamental theorem of calculus, part 1 and 2. First of all, I'm going to present FTC part 2, and we're going to use this proof to prove FTC part 1. So the proof of FTC part 2 is as follows. We have the integral from a to b f of x dx equals big F of b minus big F of a, where big F is an antiderivative of small f on the closed interval a and b. And we know the value of big F of b is bigger than the value of big F of a because here in the graph it shows that we have a positive area. And also, the integral from a to b f of x dx equals the area function from a to b. And this graph represents this proof where we have the value a and b, and we're trying to find the area between them. And now we're going to have Robert to present an example for FTC part 2.
Hello class, in the example we have the integral from 0 to 2 x squared dx. We find the antiderivative of x squared, which gives us 1 over 3 x cubed from 0 to 2. We first plug in 2, which represents big F of b, which gives us 1 over 3 times 2 cubed plus c. Then we plug in 0, which represents big F of a, which gives us 1 over 3 times 0 cubed plus c. Then we subtract 1 over 3 times 2 cubed plus c minus 1 over 3 times 0 cubed plus c, which gives us 8 over 3 plus c minus 0 minus c. The c's cancel out, which ultimately gives us 8 over 3 as the area from 0 to 2. This graph is a representation of the area from 0 to 2. The shaded area is the area from 0 to 2. Now Chris will present FTC part 1.
Hi class, now I'll present FTC part 1 by using FTC part 2. So we are going to prove g prime of x is equal to f of x by using g of x is equal to integral a to x f of t dt if it is continuous on closed interval a to b and differentiable on open interval a to b if x is greater or equal to a and less than or equal to b. So first we're going to take antiderivative of little f of t. So we're going to get g of x is equal to big F of t from interval a to x. And by using fundamental theorem of calculus part 2, we're going to get g of x is equal to big F of x minus big F of a. And we're going to take derivative to find g prime x since we need to prove g prime x is equal to little f of x. So g prime of x is equal to little f of x times, since it's chain rule, we need to take derivative of x and times that. So it's going to be little f of x times 1 minus 0 since big F of a is a constant. So g prime of x is equal to little f of x. Now I'm going to show you guys the example for this proof. So the example might be find g prime of x if it's given g of x is equal to integral 0 to x t sine t dt. So first, I'm going to take antiderivative of t sine t. So it's going to be g of x is equal to big F of x minus big F of 0. And then I'm going to take the derivative to find g prime of x. So g prime of x is equal to little f of x times 1 minus 0. And g prime of x is equal to little f of x. So we know f of t is equal to t sine t. And if you plug it in, that x to the t, then we get f of x is equal to sine x, and these two matches together, so it works. Thank you for all for watching this educational video.